vector components and how to add vectors. Okay, here is a circle divided into quadrants, superimposed on a grid. You might have seen a circle like this for the unit circle in geometry or algebra 2 or pre-cal. You can think of the grid as just your usual Cartesian coordinate system. Here is a vector. Let's call it vector A. Its magnitude is r. Because here, it kind of looks like the radius of a circle, right? Okay, theta is the angle between vector A and the positive x-axis. If I draw a line, all right, from where vector A ends straight down to the positive x-axis, then I've now formed a right triangle. The length of that purple line is equal to the y component of my vector A. I know the green line's a little hard to see, but if I go from the origin to where the y component intersects, all right, I get ax. And this is the x component of vector A. So you notice that these two do not have the vector arrow and they have a subscript, either x or y. Okay, so now this is just one of our trig ratios, cosine of theta, adjacent over hypotenuse. So the adjacent side to angle theta is ax. The hypotenuse is length r. Similarly, sine of theta is opposite over hypotenuse. So it's the y component, ay, over, again, r. But this isn't really useful. Usually, we're not solving for cosine of theta or sine of theta. So let's rearrange these. If I multiply both sides by r, I get r cosine theta equals ax. And r sine theta equals ay. These two equations right here are probably the two most important ones to actually learn out of this unit. So you can rederive these every time you have to take vector components, or I highly recommend that you memorize that the magnitude of the vector times cosine of theta, right, where theta is the angle between the positive x-axis and your vector, equals ax, and r sine theta equals ay. So there's one other thing that you might need to find, okay? Say you had the two components, ay and ax. Well, I think you guys can probably know that you use the Pythagorean theorem to find the length r, because it's just a right triangle. But how would I find theta? Well, the one other ratio we haven't used is tangent. So tangent of theta is opposite over adjacent, so it's ay over ax. So hopefully you guys are familiar with the inverse tangent function. This is not 1 over tangent, okay? It's like undoing the tangent function. So it's the inverse tangent of ay over ax. Okay, so why do we even need vector components? Well, we have to add vectors in physics. One of the biggest reasons we add vectors is when we get to forces. If we're going to add up all the forces acting on an object to figure out if they're balanced or not, unfortunately, forces won't always be in just the x direction or just the y direction. So we're going to need those components. So to add vectors A and B, add their x components, add their y components, use the Pythagorean theorem to find the magnitude of the resultant vector. Remember, that's what we get when we add them. And use the inverse tangent to find the angle. Okay, so this looks like a big, long equation, all right? But individually, these aren't too bad. Okay, so you'll notice that underneath the radical, I've added the x components. I've added the y components, okay? Each one is squared, right? And those two quantities are added together because that's the Pythagorean theorem. That's what the square root is there for. Okay. And then here to find theta, which remember theta is going to be the angle between the positive x-axis and my resultant vector, I'm going to take the tangent inverse of ay plus by over ax plus bx. So that's going to be your opposite over your adjacent. Now, quick note, you will want your calculator in degree mode. When you are finding components, you want to leave your angles as they are. When you're using the inverse tangent, you will want to kind of use common sense to figure out what quadrant you want to be in. Whoa, whoa, whoa. What was that about common sense? Okay, so if your angle is more than 90 degrees from the positive x-axis, then for components, use the angle as it is, all right, and the negative signs will work out as needed. So say it's 135 degrees. So that's actually going to give you a negative x value, right? You're going to cross over onto that side of the x-axis. So if you just plug that in your calculator and you take the cosine of theta, it will be a negative number. Okay, inverse tangent is where it does get a little weird. And frankly, I say common sense, but that's only when you have to sit down and think about it. You got to get used to it. So here are the rules. Okay, for quadrant 1, you just use the calculator value. Okay, for quadrant 2 and 3, you add 180 degrees to the calculator value. And for quadrant 4, you add 360 degrees to the calculator value. You don't need to know why, just know that this ends up giving you the right answer. Now, I know remembering what quadrant is which is kind of confusing, so here's a picture. Quadrant 1 is the one that we're used to working in with everything positive. All right, and then just like theta, all right, in the unit circle that you've learned about previously in math, all right, just like it starts out on the positive x-axis and then goes counterclockwise, so do the quadrants.